Раз. Всем привет.
My presentation brute forced in 60 seconds. What I mean here? The testers very often see a task of having a service in the form of a login. If they can't find any vulnerabilities there, we just need to know the login and the password to be authorized and analyze it. What are the ways to find out the login and the password? The simplest way is to ask the customer. If they're interested about the deep analysis of the system, the customer will provide the login and the password. You can also get a valid login and password through social engineering, but not all of the customers can do so because some of them consider that this would be too powerful. So we're not going to find out anything about that. And the next approach is to find a combination of the login and the password. That's the best and the worst option at the same time. When we don't know any of them, it's number one, which is bad, and number two, when we know the login, here we have the option of having an ordinary brute force or the dictionary-based attack or hybrid attack, whatever. I would like to say that by saying cracking here, I mean online cracking, which is different from offline cracking, and the difference is huge and pose limitations. First limitation is the throughput capacity of the link. I could not, for example, analyze more than 500 passwords per minute. With lower speeds, the performance drops, and the server performance is also important here. Please consider that. We also have some account blocks methods which may signal the brute force attacks. We have different other ways of reducing the throughput capacity of the channel. A simple substitute of login password is not our way. We use the dictionary-based method instead. Let me explain what helped me make that attack more effective and find a password in a minute. What dictionary to use? We didn't want to get many valid passwords, but we wanted to get a valid account to study the system for other vulnerabilities, and then will help us get the admin rights. The dictionary should be big enough to increase the probability of finding the appropriate password. At the same time, it should be small enough so that we can finish this on time, and it should satisfy the password policy of the company. Not all of them do. We had 63 million passwords, and only 54,000 out of those millions matched the password policy of the company. So our goal here is to get a dictionary with the highest density of probable passwords. How do we reduce the size of a dictionary and increase the probability of using the passwords? First of all, use the work lists. We use work lists, word lists, analyzing how often this password was used in the system. We take top 100 passwords, for example, or we can make our own dictionary. We can invent and come up with a dictionary for password generation. Strangely, but it works. Or we may generate a password by using the password generation rule. And the third way of generating the rules, finding out which would be the most popular rules and using them for password generation. Let us take a look at another example. It's a real story of how these heuristic methods do work. This company, they use this standard password, which matches the password policy. 8 symbols, 1 capital letter, 1 small letter, digits. Only 50,000 out of millions of passwords suited that policy. So we put Shift AZ and 1 and we release this shift. And we slightly change this rule, add 15 more passwords and try to get even yet another 10 users. It seems like that each password was guessed and detected for approximately 1 minute, and we can create some more combinations. We added more passwords here. So the following statistics was taken here. By using the standard password, 15 accounts were compromised. By using just 15 variations of standard passwords, additionally 10 more accounts were compromised. With more complicated options, 3 more accounts were compromised. This password combination was not seen in the keyboard combinations, but we saw it in a bigger dictionary. We could have just verified these passwords generated by the big dictionary. And here we have some password rules. I think most of you knew that when we create an account for our email, we sometimes have problems choosing the username. Maybe in a parallel universe you can see some messages like that, and this password is used and this login is already used, this username is used. But users do tend to create similar logins and similar passwords. And they follow some simple rules. For example, there is a language for password transfer. And we have a list of base words, which allows us to create this dictionary by using these rules. This approach has its own deficiencies. For example, they don't have normal dictionaries with rules. We only have huge dictionaries and they are not suitable. They are not sorted out. They're just grouped. And the generation of rules there is random. This rule generation method has quite a number of deficiencies. What we can do instead we can generate some rules by different methods. What I did here, let's see how the majority of the users create these passwords. They take some base word, like a name or a birth date, because it's easy to remember, and they transfer this basic word by adding a suffix or a prefix to it. For example, a password can be transferred with this prefix like that. We have base words, a name and the birth date, the date of birth. That's what we end up having, this type of password. And actually the lists of the passwords on the internet prove that it's true. When we can do it in the other way. For example, we have a dictionary which we have downloaded from the internet. Let us use a list of words and cut out all of the base words from the initial dictionary. I did not cut out password, but it's okay. Then we just delete everything which does not contain base words. And let us now count the number of matches. So it seems like that we ended up having the preferred prefixes and postfixes and suffixes, and we can apply the hashtag policy here, creating the passwords. So that's what I used here. Added the more popular passwords. Then we can combine these two charts with rules and add up the following chart, having the more popular rules. And I would like to show you some statistics. Right here on the chart we see the top 10 names used for passwords. The second chart is showing you the distribution of top 500 words. What's curious here is that the popular names are less than passwords. On the right hand side you will see the next thing. Out all of the passwords, we have some passwords from top 500. They contain this word, and 5 to 30% is a password which contains a name. Which saves you quite a lot of time. So when we have the corporate test, if we know the login, we are likely to know the name, we are likely to know the initials, which we can also use. Here I'm showing you the following. The red chart is the distributions of the base words from top 500 according to statistics. In gray we have the names transfers and how people use the names and passwords. They've been put in order. As far as we can see here, different rules are applied here. So if we would like to take the first 100, you need to remember which base words are used here. So on the right hand side you can see that the most popular ones are over the case sensitive. In 80% of the cases, the passwords are given in small letters, and 3% account for caps letters, etc. And we have one chart showing the top 10 of the password transformations. So, summing up, what do we need to do to most effectively go through passwords to end up with a login and a password? You need to prepare dictionaries with the transfer rules. We need to take base words. We need to collect additional information about users, their names, their ID, and generate dictionaries, conduct an experiment locally before we start it online, and then we will launch it online. I'm done. Thank you very much.